Hello team, good afternoon and welcome to ESN Academy, and we are into understanding 8085 and week 2 and session 2, and we are discussing about 8085 instructions. We have about roughly 250 instructions. We will complete all of them. Okay, so once you understand all the instructions, then start writing a programming and everything, and you know that what is the limitations of this instruction, what is possible, what is not possible. That's it. This is the box. Don't worry. This is designed by, this black box is designed by Intel. They said that this is what I can do. For example, I don't know how to cook non-veg. I know only veg cook, and if you cannot give me anything on non-vegetarian like that. That my limitations are only that. Since we are going to use that as a nice device, let us first understand what they can do. Okay, that is what our motto, and that is a way we are getting into the path of what the discussion. The trick is that initial few times I have given you that what is happening inside and other things, but slowly we should understand. If you write an instruction, you should know what is happening. That is a trick. Once you write an instruction, don't write too many things. For example, I have a microprocessor. Let me, as usual, we do the thing. Okay, now we have a microprocessor which has about A, B, C, D, E, H, L, and he has a control unit, and he has a temporary register. Now I have a memory. The data coming, the moment I give a power 5 volt, the microprocessor gives address 0 always, line 0. This is 78. It comes here. It gives read. It's all given by microprocessor, and it gives write as a 1, and it accepts the data. Now what is coming? Line 0 is 78. It gives 78. The 78 is latched here. Sorry. Control unit and IR, instruction register. The 78 is latched here. That's it. Now that goes to control unit. See, please understand, I take the 78 and latched into the IR is called, that is from memory to IR, instruction register. The instruction register is nothing but a 8-bit D flip-flop. 8-bit D flip-flop, please. That is 8-bit D flip-flop we called as a IR register. A register is not a register, latch, all of them are flip-flops. Please understand. Your RAM, everything is flip-flop. Now, this operation is called fetch. This operation is called fetch. I am fetching the instruction. Sometime, this one instruction itself will tell me 78, will tell me that, hey, Baba, I understand. I don't need any more instruction. If I say sit, you sit. Am I right? You do not need any more information. One command, stand, you stand. You don't need more commands. Now, if I say that add, what do you add, man? You cannot add anything. I have to tell you that add. I have to tell you that add 45 and 55. I mean, I should tell you the numbers. So some will tell you command itself is sufficient for like move A comma B. There in the instruction set table, move A comma B is 48. Sorry, 78. That is fine. That is enough. That goes to IR. After it gets 78, our man, control unit, will start executing. Okay. Now, the control unit thinks that, let us say, move immediate A. Then you are asking him to move immediate A, comma something, 45. Then the control unit understands that I need one more number. Otherwise, I cannot perform the operation. To perform the operation, control unit will decide whether I need one more or not. If he gives 78, he will decide. He's such a good logic is there. Okay, I can tell you the logic thoroughly later. Maybe after about 4 or 5 classes, I can tell you the logic very clearly. By the time you'll understand this. So, what I'm trying to tell you is that don't get confused all these things. You should know that if you write here, move immediate A, 35, move immediate B, 46, move B, C, move C, D, move A, D. If I ask you that, what is in D? What is in D? You should able to tell me. Can you able to tell me now? What is in D now? Sorry, I did a mistake. What is in D? 35. That's it. So simple. Okay. So you should be able to, you do not have to go confused. If you start confusing all the opcode, everything, no, that's not. These are all for you to understand, I told. This is not to give you the confusion. That is his job. Your job is to understand this. What is in D? How come I got 2 answers now? Is there anything I did a mistake? Yeah, fine. Now people got a... The trick is that how fast you do that. That's the only thing. Now I say that move immediate A35. So 35. Write that. Don't do anything. Then move immediate B46. I've written 46. Then move B to C. B to C. C become 46. C is gone. Whatever is there, XX. Everything is XX initially. On power on, all are having XX. On power on, all are having XX. I do this. Move immediate A, 35. 35 is stored here. Move B, 46. 46 is... Whatever is that previously is gone. Don't worry. Then move C, B. What happened? B, C. B, C. That means that B to C. 46. Then I say move C to D. 46. Then I say move D, A. So it's gone to A. A is gone now. Now all the registers become 46. Is it clear or not? If these instructions are clear, 5 instructions, then you have done. You understand about move immediate and move. Don't worry about that. Please understand, you cannot think. These are all given by the microprocessor manufacturer. That is what he behaved. You can ask me that why this is happening. No, these are all given by him. Use that to write your own programs or whatever it is. Now, it means that we see that we have discussed now move A to A, A to L, about 7. A to B to A, C, D, E, H, L, 7. And like that, finally L to A, up to L to L. So we have that the move instruction is about 49. Now 49 you write here. Plus. Then we have discussed now. We have discussed move immediate. A, comma, some number. Please understand, all the numbers are only binary. All the numbers are binary. I could have written 46 here. I could have written 46 here, but it's not 46. It's actually 0100 0110. It's all you cannot. This guy will never accept. This guy will accept only binaries. So don't get confused. There's nothing called decimal or hexadecimal. When I discuss with microprocessor, everything is binary. But instead of writing 0, 1, 1, 1, 1, 0, 1, 1, 0, 0, it is boring. I've written 7, 8. So short. Okay, that's it. Like we say that thank you, TQ, thank you, like that. It's I've written a very short form. That's nothing else. So hexadecimal is a short form of binary. There's nothing called hexadecimal and binary. Both are same. Okay. The only thing is you sort it out the binary. Now, so you have discussed about 7 of them. Now 56 is over. That's the way I do that. The way I do it with you also. How do I finish them? Now, let us start getting into a little bit of arithmetic operations. It is a small arithmetic operation. I have registers here. A to L. Then I have a ALU here. Okay, arithmetic operation. Now, first we discuss about addition. Adder. To add, now lagging, I have removed everything, man. Now it's very simple straight board. I removed all my video also. No, move immediate is not between 2 registers. Move immediate is only 1 register. I say move immediate 1 register. Anything you can say. A to L. 45, 33. You cannot, there's nothing called move immediate means 1 register, 1 number. That's it. Move immediate means 1 register, 1 number. The moment you start writing programming, you will understand thoroughly. Now I give a top level, what are these things? It's a very, I told you, this is a diggy-dangy. This is like a grammar and thing. If you don't understand the grammar, you don't understand, cannot talk. Oh, we have not discussed about M. We have not discussed about M at all. When we discuss M, you raise the point. Don't get confused now. Okay, we have not discussed about, we have discussed everything within the microprocessor. I'm not going out now. Okay, I don't do anything outside. I'm doing only inside. We are going to discuss everything. I told you now, I will discuss all the 250 instructions. You ask me any doubt, we'll discuss. But there's a method of, I have my own way of explaining. Okay, now, if I have to have an adder, I perform 2 numbers to add. That's what my adder. The adder inside the 8085 perform addition of only 2 numbers. Only 2 numbers. If we say add B, if we say add B, we don't understand this. But you know one thing, what our man says, 8085. If you say add B, he says the equivalent here is A plus B, they put the result in A. You understand? Or you can write like this: A plus B, put the result in B. If you put add L, that means that A plus L and put the result in A will be gone. Let's say if A is having 45, L is having 21. If you put add L, then what he will do, he will take A, he will give 45. He will take 21. He will perform the addition. 45 plus 21 is 66. He will give out 66. Then it will be replaced with this. The A will be gone. The 45 in A is gone now. Gone. You cannot retrieve back. There's nothing called by mistake I removed the file. Can I retrieve it back? This is all very low level. You cannot, nobody to recover at all. It's gone. Recovery is not possible. Once you have overwritten data in the memory, recovery is not possible. Please, that will be very clear. The registers, if you overwrite, the recovery is not possible. Understand? That is what he says. Let me show you that instruction also now. See here, add. See here, add A, B, C, D, E, H, L. Everything is having 87, 80, 81, 82, 83, 84. That's all. If you say add L means 85. If you give him 85, for example, if you give him 85, here, if A is 66, if B is 21, okay, if you give 85, if A is 66, B is 21, he understands, then our man gets 85 instruction register. Then is only one instruction. There's only one byte. You don't have anything to follow. But we also have something. You have something called add immediate, like move immediate. If you say add immediate, 75. Then you should put some number, maybe 89 or whatever it is. Then 75. Then he understands 89. Then this is called move immediate, add immediate. Then he takes 75. Then he add that instead of L, he gives 41. The 41 here, 45, sorry, comes here. Now HL don't come. The temp goes here. Temp goes to adder. The temp goes to adder. What is there in the temp? 75. Then he performs the addition. Please understand, there is a trick here. This trick you understand. That is, when I say add B, then A plus B into A. Put the result in A. If I say add H, I say A plus H and put the result in A, not H. Now, if I do that, add immediate 75. This is actually like this. Move temp, comma 75, add temp. You understand? This is a split of this instruction, but you don't see that. Okay. You don't see that. Okay, that they do it automatically. They're moving the, that's the way the instruction has been designed, the control unit design. It takes a second byte 75 and put it on temp. Then it performs the addition. So all the immediate means that the value comes here. That this is called, let's say W. It comes to W. Okay. The temporary is called W. So you do that add plus W. Is it clear? Like that, like add, I have a subtractor. If we say subtract A, so I subtract B, I say A is equal to A minus B. Okay, these are all the very, very simple one. And for example, if I write this code, now forget about this. If I write this code now, try to understand now. I say move immediate A comma 45. Move immediate B comma 21. Add A comma, sorry, add B. Move D comma A. Move immediate A comma 65. Subtract B. Move E comma A. See that I perform the operation. See, I'm moving A 45. Then I'm moving B 21. I am performing the addition. Some doubt? Please, these doubts don't ask in the direct message. Then there is a so write it on public. So that means otherwise I will tell you now. The question is why register A is chosen as a master storage for all operation. That you have to ask Intel. Okay, he wanted to have those days. These are all the limitations, man. Today you have latest thing and all. Add R0, R1 and put the result in R2. This is possible. Today it's having in 2021 in processors, but in those days we do not have the all. These guys have done with lots of struggle. You are asking at the peak time. This is you know one thing. Let me be honest. Let me tell you some, not honest. Let me tell you some real life story. In 1994, I started a company at Chennai about network training and other things. I have to apply for a phone. I don't have a phone. I have to apply for a phone. You know, when I got the phone, 1996. When 19? So, can you able to think today? About 25 years back, if I have to apply for a phone, I have to wait for 2 years. No, whichever instructions, you should have one more data. Okay, that temporary is used. Not all instruction. Let us say that if you say that add B, I don't use temporary because there's only one instruction that goes to IR. But if I say that move immediate A, I have one more data that I go to temp. If we say add immediate, it goes there. So this you should be able to understand. That is, we are discussing very slowly. I don't try to load with all the instructions. The trick is like this. Let me tell you the trick. The trick is first, don't think too much. If somebody writes here, move A comma, sorry. See that I've written a program. What it does. That is what if you know that what it is doing, Then you understand. Slowly, I told you now, let's not be hurry. I'm not in a hurry. I've written now A, B. See, the problem is we were in a hurry, then only we lose a lot of things, which I don't want. H, L. Now, when I say move immediately A, comma 71, 71 goes to A. But what was there previously? All XX. You don't know. When you power on, when you give a power 5 volt, you don't know. All of them are XX. Please understand, all of them are XX, not 0. Now, add immediate 43. What you are doing now? Add immediate means A plus 43, put the result in A. A is how much? 71. So 71 plus 43, how much? 4, 7 plus 4 is B. 11 means B. Yes, only 2 G's. B means 1, 1, 1, 0, 1, 1. That is 11. 4 is 0, 1, 0, 0. Now that goes to A. So A becomes now B4. Now what is gone? 71 has gone now. I have written here, move A to B. So this guy is moved here. Done. Now you have written move immediate A, comma 21. Now this is gone after the 4th instruction. Then add immediate A, comma 40. So A is how much? 21. A, comma 40. A is 21. Now 40 plus 21 is 61. Now that becomes A. A becomes 61 now. See, I'm not confusing now. See that how I do that. Then move C, A to C. So now 61 I'm moving here. Am I right? Okay. Now what I do, move B to A. Now this goes here, B4. Whatever is data old is gone. Now I say add C. That means that A plus C, put the result in A. Now what happens? B4 plus 6, 1. Now what is happening? 4 plus 1, 5. B plus 6 is how much? B plus 6 is, B is 11. 6. It becomes 17. When it becomes 17, it's a very unfortunately, this can go up to only 256. So now I subtract 16. I put 1 goes here. Then there is one more 1 is coming now. That is called, we call it as a carry. B4 plus 6, 1. I added it become 115 in the hexadecimal. Okay. This is 256 plus 16 plus 5. How much? 2 plus 3 is 272 plus 5. How much? 277. Now you add this number, B4 and 61. Add them, you get 277. Now what is happening? There is a bit here. What bit? There's a bit in the extra. This is gone because I can put now only, this is 15 only can go here. Then what will I do? So this guy, who? Our 8085, between here, H and L, he allocated one more register called F. That's why they given a name called F. In that, there's 1 bit they allocated for this. That means that if you add the two numbers, you added this number B4 and 61. When you add that, because add C, A was having B4, because I put B to A, B4 and 61, A plus C, 4 plus 1, 5, B plus 6 is a tough, 11 plus 6, 17. That means subtract 16, it goes 1 here, then 1 goes here. This 1 is not lost. The 1 is also saved here. The bit called carry. This is called, F is called flag register. How are we going to use the carry? That's our next discussion. Am I right? So we saved the carry and we are going to use it now. How do we use it? For example, I have instruction called add A, add B. Add B means that A plus B, put the result in A. Am I right? That is what we discussed. Now, they have another instruction called add C, ADC. That means that A plus B plus carry, that bit, only 1 bit. Only 1 bit. This is 8 bit. 8 bit and 1 bit. Okay. For the same thing, you add 78 plus 49. When you add, you plus 9 plus 8, 17. You take the carry, 7 plus 4, 11 plus 1, 12. Am I right? Put the carry. So that is saved here. So if you do the operation, if there's a carry comes that is not lost, that is also this gets stored. Where you have to do that. Now that's why you know that for example, your 8051 or Atmel, that Atmega 358. Okay, that's what you use in Arduino. PIC microcontroller, 8-bit. All of them, even though they have a 8-bit microprocessor, if you say that short A, comma B, comma C, A is equal to 1, 2, 3, 4. B is equal to 4, 5, 6, 8. C is equal to A plus B. This is 16-bit, but your microprocessor is 8-bit. That we will discuss next class. How do I use this 8085 to perform a 16-bit operation? Then you will understand what is the advantage of 8086. You will know that. Okay, we'll do the small comparison. We'll do the small comparison between these two. Then you will know that what is the problem with 8085. So slowly we will discuss about the performance also. That's next. So then you will know that the use of carry. Okay, so the same way, for example, this bit, I say move immediate A is 41. Move immediate B, comma 42. What is it? 42. Okay. Now, subtract B. Now, what do you expect in A? Now, tell me. What do you expect in A? Tell me now. Anybody? I've written move immediate A, comma 41. Move immediate B, comma 42. Sub B. Subtract means you know that it is A minus B, put the result in A. Now what will be there in A now? For your simple case, I assume that assuming 41 and 42 are decimal. Don't worry about hexadecimal. Assuming decimal. The problem is you people start thinking. You should not think. You people start thinking. I don't want you to think. I want you to do it. There's nothing to think here. This is a process. This is given by the microprocessor. You think this has to be that, has to be that. No. They're all assumption. That is what I wanted to avoid now. What I'm trying to avoid is the no assumptions. There's nothing here, nothing to assume. Everything is black and white. Everything is black and white. Everything is black and white. See here, the first instruction, I put here 41. Next instruction, I put here 42. Now 41 means, let me write it here. 0, 1, 0, 0. 1 means 0, 0, 1. That is what your A. That is what your A. Then what is B? 42. 0, 1, 0, 0, 0, 0, 1, 0. Am I right? So simple. You have to subtract. How do you subtract? 1 minus 0 is 0. Understand? Now the problem is 0 minus 1. So 0 is small. So I borrow 1. But this guy himself is 0. So he borrow from here. This guy is 0. So he borrow from here. This guy borrow here. This guy borrow. Understand? Now this guy becomes 0. He borrowed. So this guy become 10. Because he borrowed, not 10. This borrow is done now. Now I borrowed 1. So this 10 means 2 in binary. So this guy become 1 now. And this guy become 10. This is gone now. And this is borrowed 1. So this become 1. Now this become 10. I borrowed 1. This become 1. This become 10. Then I borrowed 1. This become 1. This become 10. Then I borrowed 1. This become 1. Sorry, here, no, you're not borrowing here. This become 10. 2. 2 minus 1 become 1. This was 1 actually. 1 minus 0 is 1. Then 1. 1. 1. 1. What happened here? Here once again, 0. So this guy borrowed. But this guy is 0. How, where will I borrow? I borrow from outside. I make this bit as set 1. That time this guy acts as a borrow bit. This bit is having a 2 meaning. This acts as a carry bit, also a borrow bit. So I give you 1 here, I make it 1 here. Then this guy become 10. Since you borrow 1, this become 10, this become 1. Then 10 minus 1 is 1 and 1 is 1. So now what happened? Your A will have 1, 1, 1, 1, 1, 1, 1, and also your borrow bit is set 1. I might have confused you, but let it be a confusion. Watch this video. This is simple. If I ask you minus 1, how do you do that? How do you do that? Oh, 10. So no subtraction. You borrow 1, 10. 10 minus 1, 9. They don't have. So I keep on borrowing. When I borrow, this guy becomes 0. This guy becomes 10. So I borrow 1 here, this becomes 9. This becomes 10. Then I borrow 1 here, this becomes 9. This becomes 10. Then I borrow 1 here. This becomes 9, this becomes 10. 10 minus 1, 9. 9 minus 0, 9. 9 minus 0, 9. The same thing. The same subtraction here. Please understand that. No. I'm this guy. If you borrow, I will set 1. If you don't borrow, it will be 0. That is the meaning of the flag register. The flag register, okay. The flag register is only one meaning. If we say that you borrow 1, if I give you 1, I'll set this as a 1. If you don't give anything, I'll make it a 0. That is the meaning of borrow register. There's no logic. I told you, this microprocessor said like that. If it is 0 means you did not borrow anything. For example, if I put here 43, take case 43. Now, what is happening when I put 43, 0, 1, 0, 0, 0, 0, 1, 1, and 42, 0, 1, 0, 0, 42, 0, 0, 1, 0. Subtract 1, 1, 1, 0, 0, 0, 0, 0, 0, 0. So I got here 0, 0, 0, 0, 0, 0, 0, 1. But I did not borrow anything. That time, this borrow register becomes 0. Understand? This carry will act as a carry as well as borrow. If you've done the previous operation as a subtraction, this will act as a borrow. Even though they call carry, it will act as a... So borrow means, if borrow is 0 means that the previous operation did not borrow anything. If it is 1, the previous, that means that it tells me one information, man. That is, if this bit is 0, that means that A is bigger than B. If this bit is 1, A is smaller than B. Okay, that is what the meaning of this borrow bit. Anyway, you go and see this video. Once again, try to understand what is the... See, I do not want you to have even a 0.01% doubt on this instruction. This is extra, not to the other one. This is going separately. I want you to at least understand one microprocessor thoroughly. Then you will understand everything. These are all quite logical operations. Do you able to understand your addition and subtraction properly or not? That's the trick. The beauty is, like add C, we have an instruction called subtract with borrow. For example, you see that 456, 327. Now what happened? The moment you subtract here, 6 minus 7, you borrowed 1 here. So 1 is set here, you borrowed, become 9. When it says subtract with borrow, this is now you do 5 minus 2 minus 1, it become 2. You understand? Because you borrowed 1, that has to be subtracted here. Now you did not borrow, it becomes 0. So 4 minus 3 by 0. So if we do subtract, see here, if we do that, add B. The meaning is A plus B is put it on B. If we put add C and B, I put, sorry, A plus B plus carry. A plus B plus carry. Now, if we put add subtract B, then A minus B. If we put subtract borrow, B with borrow, then I put A minus B minus carry. That time the carry is act as a called borrow bit. Borrow bit. But we still call it as a carry bit, or we call borrow bit. You can call BW, borrow. So the same bit, unfortunately, act as a borrow as well as carry for. That's a confusion. They would have put a separate bit called borrow bit in the flag register, but they did not do that. I don't know. They were trying to optimize one bit. They thought they can use the other bit for some important purposes. Why do you do that? That's it. Correct. Yeah. He has given a thing. If you wanted to have this thing, it's just a good thing, which I thought I'll do next week. But since somebody has put it here, it's very good. I thought we can start from next week, the practice. But if you want to do that before that, if you have a time, sim8085.com. I thought I'll give you a demo next week. Then you can do it. But if you do it nothing wrong. These are all available in the web. You can try all the instructions. What we instruction, see, whatever you do, I don't mind. We have to be thorough with 8085. That's what our job is, to understanding 8085. So try to understand 8085. That's it. Okay. Yeah, that's good. Somebody has have a very clear instruction. $77 and BB. Am I right? What is it? What is it? Wait, this is no meaning here. If I do the instruction, that's what you wanted. Am I correct? Do I write it very clear or not? You always write it in direct message. So that's why others could not able to correct it. Let us be, don't go it on direct message. If you do this, it's called add carry immediate. There's so many ways you can do that, man. I can do this as a move immediate, B, BB. Add move immediate, B, BB. Add B. Add CB. Both will get you same result. Both will get you same result. They will not differ. They will not differ because they don't have a carry set. Before the operation, if carry is set, then they will do the thing. I don't know. I assume that carry is 0 before the operation. Try it out on the simulator or try to understand. Otherwise, we will discuss on next class this carry and borrow once again. You know, very important. How do I use carry is a tricky one. Now, most of the people, the problem is very simple, man. These things are very easy to score marks in the college. You get full marks if you know these instructions very clearly. You score really full mark. There's nothing is there in your exams, college. So if you do both, it will become same. Don't worry. I will tell you tomorrow the operation of how to use the carry.